I'm back again. So today we're going to be doing some more practice for data cleaning that I think you've been doing earlier in this week and previously in the course. So we can go ahead and dive in because we have a lot of exercises in today's case. And I want to say before we get started that for me, when I looked over this case, I thought that these were pretty advanced. So if you also find as we're going through this code that it feels pretty advanced to you and you're feeling a little bit confused, that's totally fine. I would say that one of the best ways to learn how to do things that you've never done before is to look at kind of a scaffold or to see someone else do the code. And then you can use that same code in your future project or future work and just have an outline already made for you. I reuse a lot of my code in different projects that I've made before, and I just modify it for whatever the purposes I need it currently. So I just wanted to say, if you completely understand all of this code, that's awesome. And that's really great progress. But I just wanted to say, if you're feeling a little confused about it, don't worry. This is the way you learn, just by watching, by seeing how you would execute a particular function. So let's dive in today and see. Okay, yep, I just wanted to make sure everyone is good in the live chat before we start. Okay, so yeah, so the goal of our case today, and then obviously you can follow along with getting your packages imported. We are going to work on data cleaning, like I said. So we're going to work with an unclean data set, and we're going to continue on with what you've been learning and do a couple of more advanced things in terms of different ways you can clean your data. So we're going to be working with Yelp data. So working with reviews for restaurants and hotels, different businesses. So our task today is that we're going to go through the data and make transformations or additions to our data based off of particular qualities. So there are a couple of different things we also want to do. Our goal is to, for each business, find out the county and state it is a part of. Also, calculate the total number of reviews received and the average star rating across those reviews. And then calculate the total number of check-ins by hour of day, by day of week, and across all time. So before we can get to that, the first part of our case is going to be working on cleaning our data so we are able to start making some calculations for it. So the first thing that we need to do is read in our data. So these are pretty large data files. So for the purposes of being able to work with it on our kind of local hard drive, or on the server, we're only going to load in the first 1,000 rows. Since these are really large files, it can just make things run really slow if we were to load in the whole thing. So we're going to load in 1,000 rows for our reviews. We have a data set that we're going to call reviews, a data set that we're going to call businesses, and then we're loading in a JSON, the first 1,000 lines of it, as a list that we're going to call check-ins. Okay, so one of the first things after you load in your data, it's always important to look at it, just to inspect it, to see the format, to look at the columns and things like that. So this is what our reviews data set looks like. So we can see that we have dates, we have business IDs and review IDs, and then we have some numbers here for our actual reviews. So it's important for us to know, that some of our data is in numeric form. Some of it is, IDs and text. So this just gives us an idea of what we're going to be working with. And the same for businesses. So we can see that we have a business ID that will likely overlap with our business ID from reviews. And then we have the name of the business. We have some location coordinates, and we also have the city and then the category of the business. And then there's a summary here of all of those different columns. We didn't look at the check-ins, but that's just going to be a list of the business ID and then the date for when users have checked into that business. Okay, so the first thing that we're going to start with is our null values. So that's pretty much what we're going to do for the first half of this is how we deal with missing data and null values. So if we start with our reviews data set, just as a reminder, the reviews data set is this one. Okay, so this has all of our reviews in terms of the stars, ratings for cool, useful, things like that. So we want to check if there are any null or missing values here. So we say reviews dot is NA any, and so this will iterate through the columns and tell us that yes, wherever we see a true, there are missing values in those columns. So we have cool, date, funny, stars, and useful all have missing values. So we're going to figure out the best way to handle missing values for this data set. And we will go, column by column. So the first thing that we're going to do is the date column. So for our date column, it says, since the client has indicated they will likely be using the clean data for numerous analyses later on, removing rows of missing values or even writing in meaningless filler values will not work. So we need to figure out a sensible interpolation method. So that just means that we want to figure out what's the best way to fill in those missing values. So for exercise 1, given what we know about the data so far, which is pretty little, right? Describe a sensible interpolation method that we can use. So let's take a minute, and if you want to put it, think about this, and then let's use the live chat. How do you think that we should handle this data for the date column, right? We have a lot of missing values here, and we want to know the best way to fill those in, because we don't just want to get rid of all of that data. We are going to be using this for future analyses, and it's important to our client that we figure out the best way to handle date. Okay, so there's a good hint in the live chat, a good question. Are the review rows arranged or sorted chronologically? So yes, it appears that they are. So that is a good hint and a great question. So it does appear from our data set, and if you can also on your own scroll through. I did the head command, so we only looked at 5 of those rows, but you can look through and it does appear that they are chronologically. Yep, so this is great. We are going to try to complete this data. We're going to try to fill it in. And if we know that the data is organized in order, try to think about a way that we could actually fill in. You don't have to come up with the code right now. Don't worry about that. But think about, just the thought process you would go through, some way that you could fill in those missing time points. Okay, yeah, there are some great ideas in the live chat about interpolating chronologically. Yeah, based on the previous and next date rows. That's spot on. That's a great answer. Yeah, depending on the frequency. So yeah, these are great answers. I don't know if you already have the code for the answer, but if not, then that's a lot of you're saying exactly what we're what we're going to do. So let's go over this answer. I know I didn't give very much time for this, but we have 9 exercises. So I want to make sure that we're able to discuss them all. So, and there is some code here. And if you do not have this code in your notebook, I'm not sure if you actually have this. It will be posted in polls and answers for you as we go along. So there were some great answers for how we would fill in this missing data. So if we know that the date is organized in our data set chronologically, it's going in order from earliest to latest, then what we can do is write some code here that will help us to fill in those values in increments. So that means that, let's say we had one value starting at 10 minutes, and then we have 3 missing values, and then our next value is at 40 minutes. What we would need to do is we want to do increments, right? So we would want to evenly space those missing time points in between that 10 minutes and that 40 minutes to go ahead and fill in. So that's not, we won't necessarily know if that's correct or not, but it's usually it's an okay assumption here to go in and evenly space those data points in those missing values, because we do know for sure that those missing values are in a certain range. We just don't know the exact time or date for them. But going ahead and making those even increments to fill in the data is okay in this case. So this is the code for how we're going to go ahead and do that. And I guess there's a good example here that's talking about a good point to make is that, let's say we have a block of 10 missing values. If we have these 10 missing values, and let's say that we would want to make things not in increments of 1/10, we would want to make them in increments of 1/11. You're actually going to need to divide, let's say we had that 10 minutes to 50 minutes, and let's say we have 10 blocks in between. We would take 50 minus 10, so that's 40, divided by 11 instead of 10. We need to divide it into 11 increments to fill in our missing values, even though we have 10 missing values. So the way that we're going to do this is that we first want to make a new variable that contains from reviews, because remember, we're working with the date column from reviews, our reviews data set. We want to make a new variable that has only the null values. Anything that's missing, we're going to put it in this, name it NaN rows. So we're just taking the rows from that data set that are missing, and we need to define our date format. What is the format for our date column? And it's year, month, date, and then hour, minute, and second. The next thing that we're going to do is we are going to use this for loop that's basically going to go ahead and fill in all of our null values using the next available date and the previous available date, like some of you suggested in the live chat. So we're going to use iter rows. So we take our, so for index and row, in our NaN rows, which we defined here, we're going to use this iter row command, which iterates through your data frame rows as an index and series pair. So that's why we give it this pair here. It goes ahead and it will iterate through those rows. And so what we're going to do is we first, in our for loop, need to define the previous date, which is the last, if we have missing rows, we want to know what is the previous row that has actual data in it that has that date. So the way we do that is we take our reviews.ilock, which is, remember, that's the way that we can identify a row based off of like the index or the position, for example, instead of a location or unique identifier. So here we're going to use iloc, which is an integer way to define it based off of, in this case, we're going to use the index. So we take the index minus 1, which will give us the row above for the date column. And then, so what we're going to say here is if is instant previous date string. So all this is doing is saying if this instance, if the previous date, which is here, we define the previous date as the index minus 1. So if the previous date is a string, right? So we're just, all that's doing here is saying if it's a string, what we want to do is this little piece of code is saying we want to convert it into the date time, into a date time object. Okay, so right now our dates in our data set are as a string. Python doesn't recommend or doesn't recognize it as the date. So we're going to use this date time .strp time, and then we're going to use we want to convert the previous date to that date time. So previous date is this, remember, in using the date format, which we defined right here. So we have to give it a format. We have to tell it when you convert it to date time, how should you do it? And you should use this format. And then next, what we're going to say is now we're looking for the next available date, right? So if we have that block of 10 or that block of 5, we have defined, you know, what the previous date should be. We have told it, you know, you need to go to the index minus 1 in the date column. So up above, that should be your previous date. Now our next date, we're going to say next date equals none. Next date count equals 1, and you'll see why we have to do that. So we say while next date is none, right? So while that block is none, what we want to do here is try to redefine next date so it's not none. And what that's going to do is it's going to look at the next index right below the row that's missing data. So we have this missing value. So what this code is doing is now we're going to look at the row down below. We're going to say index plus 1. So we have index and next date count, which was up here we defined as 1. So that's just saying, you know, here we looked at index minus 1 for the row above. We want index plus 1 for the next row. And we want to convert that to date time. So what this is doing is it's looking to see, is there a string there? Can we convert that string down below to date time? And if so, then, you know, we can keep moving, we can ignore this. But if it pops out an error, right? If there's nothing there, it's going to pop and it's going to give us an error. There's no date time here to convert. There's no string to convert to date time. If we get that error, we have this except here, which will say add 1 to our next date count. So now that's going to tell us, that's how we figure out if we have 1 block of missing rows, 2 missing rows in order, 5 missing rows in order. This helps us to count how many missing blocks of data do we have, because we're going to do this while that next date equals none. So as long as that, you know, what we're looking for here, this will update next date, right? We're going to redefine next date as soon as we get a date in the row. Next date will no longer be none because we would redefine it as whatever that new date is. So the next thing I know that I haven't checked in for questions quite yet. I just want to explain this block, and we can talk about some questions if anyone is feeling confused. So after this, we have now, with this block of code, we have found, we have identified and converted our previous row that has data in it in the date column. We've converted it to date time, and we have found our next date, whether that is, you know, 5 rows down, 10 rows down, 1 row down. We have found that, and we've defined it as next date. So what we want to do is find the difference, because remember when I gave the example of, let's say we have 10 minutes and we have 50 minutes and we have a block in between of missing values that we need to fill in, we would take that 50 minus 10 minutes. So that's what we're doing here is we are converting, we're taking next date, whatever that date is right here that we found, and we converted it to date time, minus the previous date, and then dot seconds converts that to seconds. So we want to find that difference in seconds. And then what we want to do here is now we need to make those increments that we talked about. So we take current date equals our previous date, which remember was up here, and we converted it to date time. So we take that previous date plus date time dot time delta. So that's just a function within the date time package kind of, and time delta is just used to calculate changes in time. I guess the name kind of gives that away with that time delta. The delta sign is also used as the difference sign or difference between. So this is just the function that's used to calculate changes in time. So what we're doing here is we're taking the difference, which we defined here as next date minus previous date in seconds. And we're dividing that by next day count plus 1. So if you remember when we did here, we got our next day count to count how many different blocks we're missing. So like I said, we could have 1 or 5 or 10, but we discussed up here that if you have 10 missing blocks, you really need to take 11 in order to get the proper number of increments to fill in all of your missing values. So we take our next day count plus 1. And then we need to actually update our reviews data set that is missing these dates. So we're going to pull out those, or we're going to use this dot lock, that locate function in the date column, and we're going to update based off of the index with this current date, which we defined here. Okay, so that will update our reviews data set, the date column, with this function that we defined based off of all of this code. So I know that was a lot. So let me check in and see if there are any questions. Yeah, there was a good question about if there's a null value in the last row, then yeah, it will just continue to count. It won't actually complete your code. That's a good question. Okay, so yeah, there was a good comment in the live chat about running this code step by step. And yes, that's always a great way to learn. Sometimes in a for loop, that can be a little bit tricky. You might run into some errors there, but yeah, going through your code line by line and trying to think about what each line is doing will be helpful in trying to actually figure out what's going on here, because this is a kind of complicated in terms of all of the different steps that you have to take just to do something that sounds kind of simple, right? It's all we were doing here is filling in our missing values in increments based off of the previous available time point and the next available time point. Okay. Yeah, and good comments, or good comments in the live chat about how your code should have comments as well. And that's an excellent point. Whenever you are writing your own code, you should absolutely have comments. For now, I'm your commenter. I'm going through and I'm gonna give you the comments line by line, but it's a great point that whenever you're writing code for someone else, you should absolutely comment it. Okay. Just check, we'll take about another minute and then we will move on to our next exercise. Oh, so a good question about some why this Nan Rose date. So I don't know if I'm interpreting your question 100% correctly here, but Nan Rose, this variable, is only the null values in the date column from reviews. Down here, what we're doing is we're taking the whole reviews data set and we're adding anything that's missing. We're basically applying this function to the entire reviews data set here to update it with, to fill in those missing values. So, okay. So, this code, I would say take some time and look at that, run it line by line. There's a great suggestion in the live chat, because it can get, it's a little bit tricky to figure out all these things. But then, like I said, having this as an outline, so if you are ever needing to, to fill in missing date values, let's say with your own data, you're thinking, oh, I need to fill these in, I don't know how to do that. You already have an outline for how to do that here for this code. So these notebooks become very valuable to save this code, to use it in your future. It's perfectly fine to take this code and copy paste it and fill it in with whatever your appropriate variables or data sets are, and have this as an outline to use in the future. So the next thing that we want to do is look at so we've kind of dealt with our date column, and we have filled that in, like I told you before, in those increments to fill in any missing rows. The next thing that we want to look at is we had our star column. So the star column had numeric values between 1 and 5. So this is where people gave a review and then gave the business a star rating between 1 and 5, where 1 is the lowest and 5 is the highest. So let's do exercise 2. Describe an appropriate method for filling in the missing values of star. So think about what we might do to fill in those values, if at all. Oh, and there's a question. Oh, I think it was answered in the live chat. So yeah, there's a good question about that datetime, which is really confusing. Sorry, I'm scrolling up the live chat, so I'm seeing older questions. And that's just kind of a silly thing that first you have to, someone gave a great answer here. It's like, first you're just saying the library and then the method. So that datetime has other things within it, but one of its own functions is called datetime, which I think is silly. That just wasn't a very creative way to come up with another name. They could have called it something else to make it less confusing. And there's a question in the previous one about, is it relevant to calculate the proportion of null or nan in the data set? Yes, that is a great question and a great point. You really should find out how many null or nan values you have. If it's more than significant amount more than what your than the values you do have, you may need to handle it a different way. It may not be appropriate to fill that in because you're filling in a lot of missing data at that point. So a really great point about thinking about how you should be handling your data before you want to fill it in. For the purposes of our case today, this is more, we're just going to show you how you might go about doing it. Not, there are some good comments about the code should be commented. We maybe should have investigated our data a bit further, but this is just a good technique if you ever needed to fill in those missing values. Okay, so some good answers for exercise 2. Some people were saying to use the mean or median to fill in, checking the distribution of the values to maintain that distribution, absolutely. Okay, so these are good answers to fill in. I haven't seen, maybe someone said this and I missed it, but no one said that we shouldn't fill them in. So this is something that there's a difference, right, between filling in the date, which is something in chronological order, and we could make some reasonable assumptions about when the date, we knew the range that that date should be in. And, you know, we were told that we should fill in that date. That was something that's important to our client. But here, it might be risky to fill in star, right? Because those are someone's ratings that they gave. And so at that point, we are filling in, you know, actual data points. And this is when someone made a great point in the live chat about looking at how much missing data we have. And if, you know, we would not, if we had a lot of missing columns or missing rows in the star column, and we filled all of them in based off of the data we did have, we might be extrapolating, or we might be artificially filling in more data than what we were actually given in the data set. So, you know, it might skew our data to actually fill those in. And as you know, we don't necessarily know what the client wants to do for later analyses with star. So for now, what we're going to say is that we would fill in star, just putting in those NaN values. Just if there's no data there, replacing the missing values with a standard NaN. So another thing, we're going to say the same thing, not just for star, but for our other missing columns like cool, funny, useful, and text that we're missing. We are for now going to say that we would put those in NaN. For this case, we're going to talk about other ways, just so that you can go through the process of learning the code. If let's say that star was based off of, or was had a relationship to the columns cool, date, funny, useful, and text, you know, we will go ahead and learn how to put in missing star values based off of our other data in our data set. But that's something that you should always be cautious of and know what you're actually going to do with this data in the end, or what your client is going to do before you would fill those values in. So let me repeat myself and just say that if we were handling this data set for real, we would just put in NaN values. Okay, so that's actually what we're going to do right here. This code, using this fill NA, will put NaN values in place of any missing data for the columns cool, funny, and useful. Okay, so that is the appropriate method in this case, is that we should put in those NaN values, because we don't actually know if they are related, if they're good predictors of one another. So our safest bet is to just put in those missing, to put in NaN instead and say these are missing data points. But let's assume that our cool, date, funny, useful, and text are good predictors for star. Let's say that they are related. So like I said, that's where we're going to look at the code for this. Even though that may not be the appropriate thing here, it's still important that you learn how to do it for, you know, a data set where they might be related. So for now, we're going to say, okay, they are related. And so we want to predict star based off of our other columns of data. So to do this, we're going to use this iterative imputer. So what we're looking at here is, you know, again, we're going to check our reviews data set and say, are there any null values? And so here, if you notice, our date is now false because we already filled in those missing values. So there are no more missing values for date. We have missing values for cool, funny, stars, and useful. So let's say that we want to, now what we're going to do is fill in those missing values for all 4 of those columns based off of each other. So we're going to fill in stars based off of cool, funny, and useful. Okay, we're going to fill in cool based off of stars, funny, and useful. So we're going to try to fill in our missing values based off of the data that we do have for other columns. Okay. So now, the way that we do this is that we use this, this iterative imputer, which the way that function works is it's just going to estimate each feature based off of the others. So that's what I said. It'll put in star based off of these other 3 columns. And the way that this works is you use pandas.dataframe, imputer.fitTransform, which is used for basically training data in machine learning. But here our training data is our data that we do have. So we use this fit transform on these 4 columns from the reviews data set. So reviews, and then our columns to impute. So what we're doing here is we are basically telling it, using this imputer, this iterative imputer. It's basically 1 line of code to go ahead and do the calculations for this because it's already built in. So you use this imputer.fitTransform, which transforms your data based off of like the mean and the variance of each feature. And then you have to tell it what data do you want to do this fit transform function on, and as well as this whole function right here, we want to use our columns to impute, which we defined right here. So then we also need to name our columns, or for this imputed data frame, it's these right here. We need to like go ahead and name the output. And then we want to fill in our reviews data set. Now we need to fill those missing rows in these columns. So this is the way to just do it for stars, to just fill in the stars data set. But this helpful comment here is that you can fill in all of them using reviews, columns to impute here, and then from or equals the imputed data frame columns to impute. So you can go ahead and fill in like all 4 of them with this line of code. This right here, this right here will just fill in the stars column based off of your imputed data for stars, what was calculated. So does that make sense? How are we doing so far? Okay. Okay, I know this is a little bit confusing. So so basically an overview of what we did here, just to repeat, is that we used this function, iterative imputer, to fill in our missing data for these 4 columns based off of the data that is there. So we fill in our stars column, saying basically when we put these columns in using this iterative imputer function, we're saying we think that stars and cool and funny and useful are all related, that they influence each other, so that we can fill in those missing data for stars based off of everything else that we've seen. The same with cool, we can fill in missing data for cool based off of the data that we do have for these columns. And that's what that's doing here, is we're just filling in that missing data for these different columns, and saying that they have a relationship. And as an example, that just means that, you know, if we see more often that 5 stars is connected, you know, people who gave 5 stars also gave the number 5 rating for cool, and a 5 for funny, and a 5 for useful. If that's a pattern that has formed, where if you gave 5 stars for one of them or 2 of them, you usually give 5 stars to all of them, then, you know, you could make a guess about what, if you have a missing value for stars, but everything else is a 5, you could say, okay, we think stars is also a 5. And so that's just looking at those patterns of data and saying, do we actually see a pattern that stands out? And if there is that pattern, we can go ahead and fill in missing values. So this is a really helpful, we did a lot based off of just one line of code here, which is, transforming our data based off of, and using this imputer based off of these particular columns. And there was a question about, having NaN values in here, and does that affect things? And it doesn't really, because for our fit transform, that's looking at mean and variance. And so if there's not a number there, it doesn't really affect the data. It's only going to look for rows that have data in it. So, okay. And so, yeah, there are good questions about, should we actually know if there's a relationship before we do this? Yes. So we talked about up here that we wouldn't actually do this in real life. If this were our data set, we would fill in with NaN values because we don't know anything about the relationship or if there is one. And we don't know how this data will be used. So it might actually be skewing our data too much if we were to input these missing values. So this is what we would do if we were actually working for Yelp as a client and they had asked us to clean this data, we would put NaN values. But we wanted to go through, and I wanted to talk to you about the code you would actually use if if either your client said there is a relationship, or you went through and found a relationship, a high correlation or something like that between these variables, then yeah, you could go ahead and do this. And this is the code to do it. But in this case, we don't know anything about that relationship. So to be safe, you should fill with NaNs. But if you ever need to know how to do this, this is the code. Okay. So dealing with, the next thing we're going to talk about is dealing with erroneous values. So erroneous values, we in our previous section talked about missing values. That's where there's no data there. But what do we do if there are incorrect values or erroneous values in our data set? So that is very hard to identify, right? It's easy to say, where are the missing data rows, and what should we do for them, right? We went through a couple of different methods for how you could fill in that missing data, but dealing with values that are incorrect is kind of tricky, especially for this data set. So, what we can talk about is if we look at our reviews data set for erroneous values, all we have left is business ID, review ID, user ID, and text. So we have no way of knowing if these are correct or not for a business ID, unless you had a absolute correct list of all the business IDs that you could compare it to our data set to find anything that doesn't match. We have no way of knowing in our reviews data set if we have erroneous values. We will talk about them in our businesses data set. We can go through and discuss that. So we will talk about how to deal with some erroneous values or how to find them. But usually for erroneous values, like let's say for our cool or funny, we had these other columns here that are ranked 1 through 5. It would be easy to find erroneous values. We could look for anything that is above a 5. Right? Because we know our range is between a 0 and a 5. So if we had any values in there above a 5, then we know that would be incorrect. So if you have numbers in a range, that's usually easier. It's hard to find in these. So for the rest of our data set for reviews, we can't do anything about erroneous values because we don't really know how to find them. Okay. And there's a question of filling stars with, I think, categorical interpolation. So all of these are numbers: stars, cool, funny, and useful. These are not, in this case, they're not categorical variables. They are actual numbers. They were ranked as a 1 through 5. So that's why we're treating our data this way. It would be different if those were words like strings, but here they're numbers. So all of these were ranked as a 1 through 5. If that makes sense. So we're dealing with different numbers there. Okay. So now we're going to move on. All of our work up until now has only worked with that reviews CSV, our reviews data set that had the business ID and the different 1 through 5 rankings for reviews. We haven't done anything with our second data set, which is the businesses, that has the name, that has latitude, longitude, and had the city, things like that. Okay, so what we're going to do first is the same with the reviews data set. So for businesses, we need to check if there are any null values. And here we can see that the only column that has null values or has missing data is categories. So our exercise 3, suppose for a moment that there were missing values in the city column. So our city column, remember, just has the name of the city that the business is located in. Can you describe a method which would allow us to effectively fill in missing city values? So let's go ahead and think about exercise 3, and let's pretend that we have missing values in the city column. How could we fill in missing city values? Okay, yeah, everyone, I think so far everyone has the same answer. That's great. You are all correct. You were saying latitude and longitude. Yeah, so I think that was an easy one. So we have the exact location. We have the coordinates, latitude and longitude for each business. So we could use an external data set that contains those coordinates to figure out, what city those coordinates fit into. And we are actually going to go ahead and learn how to do that later in this case. So yeah, you're all correct. Everyone who said that you could use that latitude and longitude to fill in the city, that's perfect. So for exercise 4, let's actually talk now about the categories column that is missing data. Describe and implement the best method to fill in the null values in the categories column. So let's think about what we would do for the categories column. And yeah, while you're thinking about exercise 4, we can go back up here. I know I haven't, I loaded it up at the top here because that's a good question. Someone wanted to know. So this is what our business's data set looks like. So we have like the name of the business, and this is what categories looks like. Just as a refresher for what this data set is, and we have the business ID as well. So we're thinking about how we could fill in missing data for categories. Okay, lots of good answers. Yeah, these are all very creative answers to fill in this column. Maybe using based off of the business name. Yeah, predicting it based off of city, based off of the other columns. Okay, and some people are keeping it simple with filling it in with NaN values or with not reviewed. Yeah, so if you said the simple answer of not found or NaN values, you were correct. But I think, all of these answers that you have for filling in this data is really creative. And it does depend on what the categories actually are and how specific they get. So the correct answer for exercise 4 is that since we don't really have other indicators in the file that could help us determine the category, we will just put not found in for any missing values, because the name of the restaurant was a great idea, but what if we just had a restaurant that has a non-specific name, like I'm not sure now. Or what if it was just called like a name? What if it's Joe's, right? Joe's could be a restaurant. Joe's could be a trade shop, anything like that. So we can't always use that name, but that is a great idea. I think you're all on the right track for thinking about things, but for our data set for today, we don't really know. We don't have anything else we could really use to fill in categories in a reliable way. Okay. Okay, so I guess we should talk a little bit about this text here based off of those missing values for categories. So one thing you should do when you're looking at your data, if you find these missing values like for categories, you should pull them out and actually look at what restaurant names have those missing categories, what the data looks like for those missing categories, because it could be an error in, like this says, we could be dealing with a systematic error. So maybe it would be that every single movie theater has no category. So somehow there was a systematic error in that, when compiling that data that put missing values for categories. So it's always important when you have missing data, or when you're filling in data, it's important to do those extra calculations to figure out, or here, for example, if the business is in a specific area were not documented. So looking at location, looking at the name of the business, pulling out those missing values and trying to figure out what happened is important. Just like there were comments about, shouldn't we have figured out if there was a relationship between stars and funny and those other columns before we filled in missing data based off of each other, and that was correct. We should always do additional analysis to what's being done right here to figure out what's actually going on in our data. So let's see. And someone in the chat actually pulled out the NaN values, and there's only 2. Okay, so that's a good point. If we just have 2 NaN values, then we could pull those out and we could just say, look at them with our eyes. But if we had more than 2 NaN values in real life, this comment still holds about, we would want to look at them and find out, is it a particular area where we're missing values, where if it's a particular type of restaurant or theater or something like that. Okay. Okay, so let's go to exercise 5. Okay, so for exercise 5, what we're going to do here is we are looking at our erroneous values in businesses. So remember, we talked about in reviews dealing with erroneous values, just meaning that there are incorrect values in our data. We had trouble with that because we didn't have anything to do for business ID, for review ID, for text. That was really hard to figure out. But if we look at our businesses data set, we want to think about, we haven't talked about business ID, latitude, longitude, and name as candidates for erroneous values. So let's take a minute for exercise 5. And let's see. Describe and implement suitable methods to deal with potential erroneous values in these columns. So let's take a little bit of time here and actually go ahead and try to, in your data set, if you haven't been doing this already, try in your data set to enter in some code that you think could help us deal with erroneous data or with erroneous values for any of these columns. And actually, before we do exercise 5, so let's talk first about what columns do you think we can tackle for erroneous values. That's maybe a better way to go about this. So what do you think are the columns, based off of what we've discussed so far, of those 4 columns, what 4 do you think we can actually figure out if they have incorrect data? And yeah, an erroneous value is an incorrect value. So something that's, that we can know for sure, like I said before with stars, we know that the range was between 1 and 5. So if we found a 6 anywhere in our data, that would be erroneous. We know for sure that, 6 is not a possible answer. That is an incorrect value. But remember, we couldn't deal with business ID necessarily because we don't know if that's erroneous. That was a jumble of letters and numbers. Okay, so yeah, there are some, so the columns we could deal with, yeah, so latitude and longitude, yeah, maybe, and maybe also city. Yeah, latitude, longitude, maybe name. Yeah, if we knew what the correct name of the business should be, we could look for any errors. Okay, so yeah, so a lot of people are saying latitude and longitude. So that is correct. So for exercise 5, think about a way we could implement, how could we deal with erroneous values for latitude and longitude? So let's take a couple of minutes and actually try to write that code for how you would fix that. The latitude and longitude to find any incorrect values. So, while you're thinking about that, I'll just say, so the reason why we can't really do anything about business ID and name is that we don't know, we don't have any data, we don't have a database for what the correct name should be for the business, and we don't know what the correct business ID should be. So for now, we have to assume that the business ID that's in there is correct. We don't have anything to compare to. But for latitude and longitude, just like with knowing our what our range was for stars or for funny, that rating between 1 and 5, like I said, we could look at anything that was above a 5 is probably incorrect. These, with number values, if we know what the range should be, think about how we could figure out if there are any incorrect latitude and longitude. And yes, someone posted a good hint for what is the maximum latitude and longitude. So yeah, a good hint that I'll read out here is that the latitude is -90 to +90. And then longitude is -180 to +180. So that's a good hint for the range that you are looking at. Okay, so we're working on exercise 5. and thinking, I'll give a hint, the code is not super complicated here. So we're just taking a couple of minutes to think about how you could find those outliers, or how you could write the code. Because I know someone posted that here, the latitude and longitude in our data set might not actually have any of those outliers, but that's okay. We're just going to try to write code to, to find any, if we didn't already know based off of, I think someone posted like the max and min, some of the statistical summaries for our data, which is absolutely the right way to go to even find out if we had those outliers. But we are going to try to write some code that would find, particularly for latitude and longitude, how to find anything that is outside of those values. Yeah, and these are great points in the live chat, that someone said, keep in mind, we're only using a sample of 1,000 rows. Yes, absolutely. So we're not even looking at our whole data set here, but we're pretending if we had, our whole data set, the code we would be writing. But I love that all of you are thinking about these really good ideas for how you need to handle your data before we would do this code. I'm really impressed with all of you. I was really impressed last time I taught too. I think you all have really great ideas about how you should be working with your data, things you should check, caveats, stuff like that. So definitely on the right track for thought process. And it's a great point to say that we should keep in mind we're only using a subset of our data here. And like I said before, if you're feeling a little bit like this, this was pretty foreign or new, or you're not exactly understanding all of the code here, that is okay. If this is kind of the first time that you're seeing something like this, the more that you play with it on your own, running those lines of code, searching for things. So I, even when I was preparing for this case, I Googled a couple of the commands and things like that to find out the background on them, and just searching for it is, a great way to learn about what that line of code is doing. So I highly recommend just going through and searching anything that you don't understand in what we've talked about so far, and getting the answer to what each function actually does. Okay, so let's talk about the answer here. Okay. So I just want to make sure I'm showing. Okay, so here is our code. So there were some posts in the live chat about figuring out what the range actually is for the latitude and longitude, which was absolutely correct. So our range for latitude values should be between -90 and 90. And then longitude is between -180 and 180. So what we're looking for here is anything where so if we start with our latitude, in our business's data set, we're going to use this .loc or basically .locate function. And that locates things based off of a particular value instead of like an index or position in the data set, as a reminder. So we have businesses, our latitude column. We're looking for anything in our businesses data set in our latitude column that is less than -90, and anything in our latitude that is greater than 90. And then what we're going to do is, if we find any of those, we are going to put in those NaN values. So it's basically saying that if the latitude is less than -90, or the latitude is greater than 90, we want to replace them with those null values. So that will automatically just go through, and if it sees that latitude is -91, it's going to put in a NaN value. If it sees that latitude is 91, it's going to put in a NaN value. And the same for longitude. So we look at our longitude column. If it's anything that's less than -180 or greater then 180 for longitude, it's going to put in that NaN value. So that's one way that we could identify. That's one way that we could identify our outlier values or incorrect values for this data. Okay. So what we're going to do now is talk about adding information to our businesses column. So we've kind of cleaned our data. So what we want to do now is one of the things at the beginning of our case was our client, Yelp, wanted us to find the county and state that each business belongs to, and then add it to the table. So we're going to use GeoJSON files that have the geographic shape of each state and county in the United States. And then we're going to use the Shapely library that we loaded at the beginning of the case to figure out whether that point is present inside a shape that represents the border of each state or county. So people were saying, when we were talking about if we had missing data in our city column, how could we fill that in? And there were some good comments about, well, we have the latitude and longitude, so we could try to find the city based off of those coordinates with an additional data set. So we're going to do we are going to do exactly that, except this time we're going to find the state instead of the city, because we already have our city data filled in. So here, if we wanted to find the state based off of our latitude and longitude, let's talk about, this is the code that would help us to do that. So the first thing that we need is we need this state shapes JSON that will actually have all of the coordinates for each state, that has basically the location data. So what we do with that is we're going to define a function here. So our function is going to use the argument row. And so what we need to look for first is missing data. So if there's no latitude or there's no longitude, if there's no data there, we're going to return none. So we have to make sure that there's actually a longitude and latitude. But what we do is we're going to define our a point. Basically, what we're going to do is have lots of points, right? Each row is going to be a point, because our row is our argument. So we're going to do this for each row. But what we're doing is we're creating a point for each row for the combination of longitude and latitude, right? So I'm just going to scroll down and kind of show you. For latitude and longitude, what we were doing here is making a point out of that using this point function, which is a part of the Shapely library. So this is an actual function that makes each latitude and longitude a point, basically a point on our map. And then we're going to use a for loop. So for state in states features. Now remember, our states we defined up here. This is our geographic coordinates. This is our state JSON. So in the features section of states, we need to make a shape for each state's geometry. So what we're doing is we are taking each state, we're making it into a shape. Shape is also a function of that library. And then if our point, basically this is saying if our point that we defined here, if our latitude and longitude, our point is within that shape, then we want to return the name. So we want to get from the properties part of state, we want to get the name. So all this code is saying is for each latitude and longitude, if it fits within our state shape, then return the name of that state. So we're making a shape out of each of our states that are contained in this JSON. And then we're saying, does our business, the latitude and longitude, fit within that shape? Does it fit within that geometry in the shape that we've created for each state? And then if it does, then we want the name. And so then we're going to modify our, modify our business's data set to create a state column because we don't have one yet. We need to create that state column and then apply this function, the get state name, and axis equals 1 is for columns. So that just represents column. So we're adding this, we are applying this to our business's data set, and then this is what the output should look like. So after we run this and we do a .head function, you can now see that we have a state here. I'm not 100% sure why we got a none here when we had a latitude and longitude. So, you know, I was thinking about this before this case, I saw this before, and I'm not 100% sure why. It could be that, you know, we would have to investigate maybe this latitude and longitude isn't defined within a particular state or something like that. I couldn't come up with any reason why this would be a none since there are values here. But anyway, the main point is that we should have our states filled in now for this data set based off of the latitude and longitude that's given. So this code, let me see, are there any questions? Oh, and someone said it's in Canada. Is that I don't know if you know that for sure, but there you go. That could be a great explanation if that's where those coordinates are. I don't know if anyone looked up those actual coordinates. Oh yeah, it's in Canada. Oh, cool. Awesome. Well, that was really fast. Great, great job. Way to either know that or look that up really quickly. Okay, well, perfect. So this is in Canada, and maybe that's by the city because that city wasn't familiar to me. So that was a great job. Okay, so how about the code? So, oh, someone asked which library have this. So this Shapely library contains this. So those are functions that are within that. And then there's more details here if you click on that link in your case. And yes, it does take a long time to load. I preloaded this before class, so don't worry if it's taking a while to load. This is a big data set. And then, oh, and a good question about should we keep anything that's outside? So yeah, we want to keep all of our data, but things that are outside of the United States, we'll just fill in with a none. And you know, that's fine. We don't want to delete any of our data right now. We just, you know, this code just helps us with the United States data. I'm not actually sure how many points in the whole data set would be outside of the United States. Okay, so let me scroll through and just see. Okay. Okay. So yeah, this is really helpful code to figure out, you know, you can load any JSON. It doesn't have to be United States. It could be, you know, anywhere that you have that geographic data for. And this is a really, really helpful tool or code for you to be able to, given coordinates, assign a state to it. Or we will have another example here. So find the county of each business and add them to the table. Okay, so the other thing that I want to say for this exercise is that I think you don't actually know what the name of the county JSON is, and so that maybe I can show you a little bit. Okay, so at the bottom, this is the name of that JSON. I don't know if you had that already, but what we want to do here is add this script false no raise error because this is a really, really huge JSON, and I don't want, you know, everyone, like, you know, the server to go down or everyone to have trouble trying to run this code at the same time. So when you're thinking about this, basically what I want you to do is almost try to write what we did up above with states, but for county. But we aren't actually going to run it. We're just going to write the code for it, and we'll go through the answer, because otherwise all of you trying to do that with this really big JSON, because counties within states, there are tons of counties. So with states in the United States, we have 50 states. So that was defining 50 different shapes and looking, but counties There are hundreds of thousands. So let's, the kernel, so don't run the code. So everyone look, down here, I don't want to give the whole answer, but add this to the top, and then you can just write your code, but it won't run it. So add this script false, no raise error. And the explanation is here. The size of the file will make it difficult for all of us to try to execute. So put that in, and then try to write the code. Since we already looked at it for state, it should be pretty easy to think about how we would do that for county. And here's the name of the file. So I'll give you the first line to open that county JSON instead of state. So we can take a minute and try to write that code out for yourself that we looked at up above for adding the state. But in this case, we would want to add county in addition to our business's data set. Okay. So we're working on exercise 6 for the code, but remember, we're not running it. Okay, so add this line first so that everyone's kernel doesn't crash. And then up here, if this took a long time to load, if it's still loading, that is okay. It took my computer a long time to load also. So yeah, we're going to add the county, very similar to the code that we had up above for state. Okay, and while you are all working on that, I saw a question way earlier about that iterative imputer. So I wanted to add, because I did a quick search because I wasn't actually sure, but I want to answer the questions that were asked about the model behind that iterative imputer. I wasn't sure myself. So while you were all working, I did a quick search. And it does use a multivariate regression for that. So it uses, while you're working on county, I know that this is going back and I should have answered, I should have looked when someone asked that question. But I did it while you were all working on your code. So it's back talking about this part. So this was a question about what was the model behind filling in our extra data based off of, filling in these columns or filling in this column, based off of all the data. So what it does is it uses a multivariate regression. So it uses all of these variables, including stars. So it uses all of them to then fill in like the stars data set. And this iterative part means it does it in a round robin fashion, which means it takes this one first to come up with the data, then this one, it comes up with the data, and then this one, and then that one. So that's answer to a question that was asked a long time ago in our lecture. But I was curious myself and didn't actually know, and I should have looked that up before lecture, but I forgot to do that. Okay. So back to exercise 6. So yeah, this is a good question. Okay, so I'm looking at the live chat and there's a question about understanding the words county, state, etc. It does not understand those. So the way that we got state is from this. So we have states that we named this JSON. So we came up with that name. We called it states just for clarity. And then we said for state in states. So that's where state comes from. But Python does not understand state to be a state, we said in our for loop. for state in states. So hopefully that clarifies. Basically what we're saying is we want the geometry for each state. That's where this comes from. We were making a shape for the geometry of each state in our states data set for features. So that's, a little bit complex, but it's a good question that we should clarify, that this state here for we want to return the name that's in properties of each state is that we defined it up here. So we could have called this anything. We have usually for loops are for I in something or for J in state, something like that. So this name was just for clarity. So we called it for, or to help you kind of think about what we're doing. But yeah, Python does not recognize state versus county versus anything like that. We put those names in. That's a good question. Okay, so let's go through exercise 6. And yeah, there's a good question about the business ID column. I don't know how the business ID column was encoded. I'm not sure where this comes from in this data set. I don't know if that's, where Yelp got that from. Okay, so we're adding county. So this is very similar to our state code. You could have copy pasted your state code from up above and put it here. It's doing the exact same thing, except now for our counties data set, it's the exact same thing where we're going to look and see if there's a latitude and longitude. If not, return none. Otherwise, we're going to create a point from each latitude and longitude. And then we want to look in our counties. Counties comes from this name right here for this JSON. For each county or each thing in our features of counties, we want to create that shape from the geometry for each county. And then we want to look and see if our point is within that shape. And then we want the name. And then we want to apply that to our business's data set. So this is the exact same that we did for states, but we're just doing it for counties with a different data set. So we gave it a different name. Okay, so the next thing that we want to do, so let's see, let me check on questions, see if this makes sense to everyone. Yeah, so don't run this code. But yeah, I see someone ran it on their local machine. That is great. I would just say, just in case, since we're still going through the lecture, I don't want anyone's computer to crash or kernel to go down or anything. So for now, let's go ahead and leave this in place. And this is just the code you would need. But yeah. Yeah, we're looking at every state and county. Okay. Okay, so the next thing, and I think for state, someone's asking about an efficient way, and this also just occurred to me looking at your questions. Yeah, I would also think that for city, you could maybe try to get state, but there are states, at least in the United States, states have the same city name. For example, you can have Kansas City, and that can either be in the state of Kansas or in Missouri, the state. So I guess that's not a very good solution. So never mind, I won't say that. It is better to go with the latitude and longitude to get the exact state, not just using the city. Okay, so let's keep going. So the next thing that we want to do is, we were asked at the beginning of our case to add information about a restaurant's number of reviews and their average star rating. So what we want to do for exercise 7 is calculate the number of reviews received for each restaurant. So let's take a couple of minutes and think about how you might organize or write your code if you wanted to know the number of reviews received for each restaurant. So now we're back thinking about, up here, we were thinking mostly about our business's data set using that latitude and longitude. But now we want to think about, we're back to thinking about reviews. So as a hint, we want to use our reviews data set. We want to just calculate the number of reviews received for each restaurant. Yeah, I see. And some people ran the code for these exercises. That's okay. If your kernel is down right now, that is okay. You can also just follow along here. And if you are still seeing, if you're seeing a little asterisk or a star, like it's loading, you can continue to write code even if the previous cell is running. So if you're still able to see your notebook and you're able to write our exercise 7, calculating the number of reviews, go ahead and try working on that. If your kernel has died, that's okay. Go ahead and follow along as we go through. Oh, and there's a good point. They're all restaurants. So I'm not sure if they're all restaurants or if that's just the wording. I guess it should say the number of reviews received for each business. But I guess. Oh, sorry. Hang on. I think it means for each business. I'm gonna just cheat a second. Yeah. Yeah, it says, that's a really good point. It says restaurant, but this should be business because we have golf clubs, Chinese restaurant, but I guess, yeah, farmers insurance, and this is financial services. So it should be every business, I think. Yeah, there are different types of businesses. So let's change that to say for each business, not for each restaurant. I'm just looking at this file. Yeah. So we want to calculate it for each business. That's a really good point that was made in the live chat. Okay, let me go back to, okay, the number of reviews received for each restaurant. Okay, and let's think about the answer. Because as you can see from this code, yeah, so it says restaurant, but we're actually going to do just all the businesses. That's just an error. So that should be businesses, not restaurant. Because like I said, a great point was made about there are different types of businesses here. There was an insurance company, a golf club. So let's think about the code that we would use for the number of reviews that are received for each business. So what we're going to do is we're going to define our function here, and we're going to call it calculate review count. And what we're doing is we're going to name this business ID and then equals row business ID. So that's basically because our argument is each thing. Like you can think of your argument as like the X in a mathematical equation. So we want to take each row or each business ID. So then we're going to say business reviews is from our reviews data set. We want the business ID column, and that equals equals business ID. We want to have and what that means is like that equals here we defined business ID. So you could basically input that row business ID here. Then we want to return the length of business reviews, which is just how many how many how many different reviews there are in that business reviews for each business ID. So then what we want to do is make a new column in businesses called review count. And then we want to apply that. So, what we're doing is we're applying. So wherever our reviews business ID equals I believe our business's business ID, then we want to apply this function to our business's data set. And we want to make that new column. And so that should calculate the number of reviews we have for each business based off of the business ID. Yeah, I'm just thinking about if I said that correctly. Yeah, and there's a good suggestion in the live chat that you could have just done a group by, which I agree with. This does seem like a complicated solution to an easier question, because I think what we're looking at here is, we're looking at our business ID from our reviews. And I think we're saying, does that business ID from reviews match our business ID from businesses? Because we apply this to the oh no, okay, sorry, I confused myself when I was explaining this, because I thought, okay, so let me try this one more time. So we're looking at our reviews for each business. So what we want to say is we're looking at each row in our business ID column. And if it's the same business ID, I was right when I thought about this the first time and confused myself when I told you all. So we're going to start over with the explanation. That's my bad. I'm sorry. So what we're looking at is we had our reviews data set and we have that business ID. And what we're doing here is we're going through each individual row of because our row is our argument, that's each thing. We're going through each individual row of our business ID column. And if it's the same business ID, so if we have the same business ID in multiple rows, then we want to return the count for it. So if we have that business ID, let's say business ID is 123. Okay, that's our business ID. And if the next row, the business ID is also 123, and the next row it's the same business ID 123. If those are equal, like, we're gonna return the length of them. So that's how we're gonna get our count. So then we are adding that to our business's data set, to our business's data set. So does that make more sense? I know I had confused myself when I explained it the first time. So what we're doing is we're just looking for if there are any business IDs that repeat, that are the same in the row, then we're going to say, we want to count all of them up. And we want to say that, there are 3 or 5 or 6 or whatever reviews for that business. So this code, I'll just explain one more time that, for each thing we're looking in that business ID column, and we are looking to see if the business ID, if it equals business ID, which means does it repeat? Is it equal to the other business ID? And then we want to return the length of business reviews. So we want to know how many times do those business IDs repeat each other? But someone made a good point, and off the top of my head, I can't think of why we wouldn't just use a group by function. And then to count the business IDs. So if anyone thinks of a reason why we shouldn't have done that, please put that in the chat, because that seems a lot easier to me. But you can also do this, and then writing this function one of the benefits is that writing this function allows you to apply that function to a different data set. So, one reason that this is advantageous is we're working with the reviews data set in this function, looking for the business IDs and how many times that those repeat. And that's from reviews, but we're adding a new column to the businesses data set. So we're adding it to a different CSV. So a function helps to do that. Okay. Yeah, and there are points in the live chat that, yeah, this helps you to apply it to a different data set. So oh, and someone actually did, the results are different using the group by and calculate review count. Okay. And it's more difficult to add it. So, for this, this way lets you add, the data from one CSV into another data frame. So this is the code here. If you're getting an error, I would double check, maybe copy paste it directly from polls and answers when this is showed, to try to figure out, why you would be getting an error. It could also be, make sure that if your kernel did crash or something, that you reran or you reloaded your data set up at the top, something like that. But anyway, so this is the way that we are calculating our number of reviews. So I just want to stop because I know I maybe made that a little bit more confusing for some people at the beginning. So I just wanted to pause and get any questions on this code. If anyone is feeling confused about what we were doing here. And I think some people in the live chat are trying to come up with other ways to do this, which is great. There are always multiple ways to do the same thing. So if you find an easier way to do it, that's great. Okay. Okay, awesome. So now for exercise 8, we have 2 more exercises left. So for each restaurant, we want to calculate the average star rating. So again, this says restaurant, but remember we're talking about each business. So it doesn't have to be a particular restaurant. It's just the whole data set that we loaded in those 1,000 rows for the business. For each business, calculate its average star rating. So remember, our star ratings are in the reviews data set. That's how we got stars, and it was at 1 through 5. So we want to calculate the average there for each business. So let's take a couple of minutes to work on that. I'll keep an eye on the live chat if you had any questions about exercise 7, what we were doing, or any previous exercises. And if you wanted me to repeat the explanation for any of them while we're working on exercise 8, just let me know. And I'm happy to go over anything that was confusing. And yeah, there's a good question about what change would we have to implement if we wanted only restaurants. And that one is kind of tricky because you would do it based off of pulling out just the categories that you wanted. So if you wanted to look at only restaurants, we'd have to look through our list of all the different qualifiers for category, and you could make a new data frame with just those rows that had a particular category name. So yeah, that's a good question. We could pull out particular categories and do some analysis for those. In this case, we are just going to do the whole data set. But yeah, you could pull out particular category names and do that. Okay. And someone asked, let me see if I can, on the fly. So someone asked what our businesses looks like after exercise 7. So this is kind of our, let me do a couple of more. Let's see if we can look at 50 instead. Oh, oopsies. Okay, that's a good point. Someone was saying that they're getting all zeros. So I'm going to assume that they're not all zeros. I'm going to assume that these top ones are just zeros. But this is what it looks like after you add that review count, after you run that code. Yeah, I see. I'm seeing the comments in the live chat. And that is very weird that there's only 3 columns that have, or 3 rows that have a different value than 0. Well, that is very odd, isn't it? And it, could be that the businesses, so maybe some of these business IDs in this businesses data set don't necessarily match up with our first 1,000 rows of our reviews data set. Like maybe these are not overlapping just because we have a list of all of the businesses. And because our list of all of our businesses, there may not be reviews for all of them. Our businesses data set might be a lot larger than our reviews data set. And in this case, we just don't, we only loaded in 1,000 rows. And so it could be that in our large list of businesses, they don't all have reviews written for them. And in this case, of the first 1,000 rows, only 3 of them have a review for them. So that would be my best guess for why so many of these are 0. And then, this is kind of a hint because this is what the stars column that you are adding, that you're working on right now for exercise 8. But that would, I guess, make sense for why there are no stars either, because these don't have any reviews. So I'm guessing that this is just the list of all the businesses. They don't all necessarily have reviews. So, yeah. So if we had loaded in the entire data sets for both of them, we would have to see what the answer looks like then. But we're not going to do that for now, just because they're big data sets, and we already had some issues with kernels crashing with our previous data. So, or with our counties data set or states data set. So we aren't going to load in all of the data for now. But yeah, it would be, if you, that would be a good thing to explore, is if that's the case, that this is just the large list of all the business IDs, and it's not necessarily true that all of them have reviews. Okay, so let's talk about our average star rating. So for exercise 8, we are writing a function for our average stars. So again, we're using row as our argument, and we want to look at each business ID. So we're going to look at each independent business ID, and what we want to do is, again, it's the same code that we used previously to calculate how many of the same business ID we have, like how many reviews we would have. So it's the same as what we did previously, where we are saying, from our reviews business ID, does that equal up here our row business ID? So if it equals like the previous row's business ID, or if we have matching business IDs, we want to take the mean then. So our average stars is going to be this. business reviews, this function or this variable that we defined right here for those multiple of the same business ID. So if we had 5, like I said, 5 of the same business IDs, we want to take the stars column for those 5, and we want to take the mean. So this is how we get our average stars. And this is, the output isn't super helpful here because we have nans, because we don't have reviews. Hypothetically, like I said, if we had 5 of the same business IDs and they all had the star ratings, them 1, 2, 3, 2, 1, something like that, we would take the average of those 5 for that business ID, where the business ID is the same. And that's what, similar to our previous code, that's what we're looking for is that business ID, does it match for the rows? We want to put together all of the same business IDs. So if it's equal, then we want to take the mean from the stars column for those where the business ID is equal to each other, so that we are only taking the average rating for a particular business and not the average of all of the stars, but just for that particular business ID. And we want to put all of the same business IDs together, which is what this is doing. So very similar code to what we did here, which was looking at the number of reviews that you received. And here, since we just did the length, that counts the number of things in the number of the number of items that are in that object. So that's what that length is doing. That just counted the number that we're repeating. Here, we're taking the mean instead of that stars for those businesses that have the same business ID that have multiple reviews. So we're applying that to make a new column called stars. And then this is what the output looks like. We have the stars column. Since we don't have any reviews, we don't have any stars, we don't have any, we can't add the average for those. And yeah, okay, so any questions about what we have done so far? Oh, and someone used, I'm just checking in on the chat. Someone did use the entire data set from businesses. Awesome. Okay, so there's the answer in the live chat. Thank you for doing that. That's very quick. So yeah, the code does work. So this is a good confirmation that there are, if you use the entire data set, then we would see those reviews. It's just that the subset that we're using isn't super helpful. Okay, I'm just catching up on the comments. Yeah, and so there are just some reminders that yes, it's this is, so far this seems to be correct that we have 0 for the review count and for the stars. If we had loaded the full data set like someone did in the live chat, then we would have we could have and we would have sorted it based off of review count. And then we could have seen that there were, or stars, we would have had actual numbers instead of just 0, since these don't have any reviews, or we could have filtered it by any review counts that are greater than 0. But so far, is this code making sense? Yeah, and someone asked why you got a bunch of nans for the result. And this is just because it put in nans because there's no data there. There were no stars, so you can't take the mean of nothing. If there's no stars, no reviews, then it puts in that nothing basically. So that is correct. If you got those nans, that is the correct, the code is running fine. There just weren't any reviews for our subset of data. Okay. And someone's asking if you can calculate this with more simple code. If you get that same answer, if you can, there are multiple ways that you can calculate this. So if you have found a way to get the same answer with different code, that's perfectly fine. One comment when we were discussing whether or not you could have just done a group by, things like that. So I think one of the things that we discussed is that a benefit to doing this is that you can pull data from one CSV or from one data frame and apply it to another. So if you found a more simple way to do that, that's, that is great. But I think, this is fewer lines of code, I think, than if you went ahead and had to apply this to your new data set. In this way, you can just apply this function to your business's data set. So I think that's kind of the caveat, or kind of the tricky part here, is that we wanted to add data from reviews for this business ID and stars, but we want to put it in our business's data set. So that's just the one thing you want to make sure of if you're trying to write other code. Okay, so let's finish up with our last exercise. We have about 10 minutes. So our final task is that we're going to use our check-ins data given in the JSON file. Now that JSON file with the check-ins, we loaded at the very beginning. So given in the JSON file to compute the various statistics on the number of check-ins over various time periods. So for exercise 9, we want to compute for each business the total number of check-ins by hour of day, by weekday, by day, and across all time. So this one is a difficult, we can, since we have 10 minutes, we'll give a couple minutes if you want to think. You don't have to write out all of the code. That would take a while, I think, to do. So just think about, the functions you might use, or in your mind, think about how you would do it. When you're writing code, sometimes you think to yourself, oh, I would want to make a for loop, or I would want to define a function that, calculates per hour of the day, thinking through how you would do it. That's fine. And then we can go over the code, because this would take a while to calculate the total number of check-ins by hour of day, by weekday, by day, and across all time. So just think about how you might do it. If you want to start your code thinking about one of these, if you wanted to across all time, something like that, we'll take a couple minutes and try to do exercise 9 or part of exercise 9. And while we're going through this, feel free if you have any questions. And there's a question about the JSON that we're using. So we're handling it as a list. So if you remember up at the top, I just want to refresh, since we haven't actually talked about the check-ins data set for a while. I'll scroll up to the top here so we can see that. Our check-ins, we named it check-ins. So remember that when you're writing your code, or when we're going through this, we named it check-ins, and we used our check-ins JSON. We loaded the first 1,000 lines into a list. So that's what we've done here. So we appended it, and by doing this, we've basically appended this into our check-ins list. So we're not actually working with it as like a JSON like we did for our state or county data. We're really using it as a list in this case of check-ins. Okay, so I want to start. Let's talk about exercise 9. Okay, so it's a lot of code here. So what we're doing is, remember, we wanted to compute for each business the total number of check-ins by hour of day, by weekday, by day, and across all time. So we're using our check-ins basically list. And so we're gonna make an empty list up here for the check-in aggregations. And then we're going to have a for loop. So for check-ins, which is that list, we're kind of creating a dictionary here called business info. So we have the ID, which is the business ID from check-in. We have total check-ins, which is the length of the date column in check-in from that list. So we basically had two things in our check-ins JSON file. We had the business ID and the date. So what we're doing is we're going to say for our dictionary ID is from check-in, or for check-in check-in. So for each thing, right? We're iterating through each thing. The ID is the business ID, and then total check-ins is the length of, or the number of objects in that check-in for the date. So it's like the number of dates. So now what we need to do is compute the check-ins by hour. So these are empty right now, check-in by weekday, things like that. So what we start with is another for loop. So we say for date in our check-in date, and then we're splitting it by comma. So that what's kind of confusing here is that we have check-in and check-ins. So this is like for each check-in in our list of check-ins. Okay, so here when we say for date in check-in date, remember that's coming from up here. And we're going to split it by comma. Our date. So the first thing that we're doing is we're taking each date and we are converting it to that date time format. And we use date format all the way from back at the beginning of our case when we define that date format. So the strip function, all that strip does is it removes any spaces at the beginning of a string and at the end of a string. So it just gets rid of any leading or trailing spaces. And so we're just converting the date into that date time format. And then what we're actually doing is then we have this defined as date, but then day string is going to convert any date if we apply this variable into a string. So that goes back from a date to a string. So you'll see how we use these different things, but we have them as different variables, right? So date is that we're taking we're converting the date into a date time, but if we call day string, that will convert the date into a string. So we have either one there. So now if we want to calculate the check-ins for each day, what we're doing is we have our business info check-ins by day, which is here. And then we want to get the day from day string here. We want this to be in a string format. So if we see that it either will be the string or return a 0. So we either want to get the day in string format or return a 0. And then we want to add 1 to this check-ins for day. So we continue with adding to our check-ins by day. So for business info, what we want to do here is then add, so we're taking our, we're calculating our number of check-ins for day, and then we have, let me see, business info from up here. We have check-ins by day, and then we have our day string, because what we're adding is we're appending to our business info, this check-ins by day. We are adding in that actual string because we want to, if you see our output down here, we want to have the actual string printed for each date. And then we want to have however many there were for that same date. So what we want to do is count the number of days that we have, like for the same day for the check-ins. And then we want to add, we're adding, 1 or 2 or 3 or however many there are. And then we're appending that into our check-ins by day up here for business info. And we want to also print off the string. And so that's similar to what we do for our check-ins by hour and our check-ins by weekday. The only difference is instead of getting the date as a string, we're basically taking the date for, we want the hour instead. So here we have date.hour. So in some cases we want to pull the string for check-ins by day because we want to count like the date as a string to see how many replicate or how many are the same. But here, if we have the check-ins by hour, we do this date.hour. So since we use date, which is in a date time format, this .hour function, we use .weekday down here. You can have .minute. They will actually just get you the hour that's in that date instead of the whole thing. So here we just pull the hour or return a 0. And then if it's more than one of the same hour, we're going to continue counting for the hour check-ins. And then that's the same thing for the weekdays. We use the exact same code and we use date.weekday and we use this .weekday. This is a function that will count it will use weekdays as 1 through 5, 1, 2, 3, 4, 5 for Monday, Tuesday, Wednesday, Thursday, Friday. And then the last thing that we do, so then we have, we add our weekdays. So this is all pretty much the same code, just repeated, depending on if we wanted check-ins by hour, check-ins by weekday. And we are just going back and we're basically adding to our business info up here. And then that's why we use this append function. All of this gets added back into our dictionary that we appended up here. And so all of these are just independent functions to basically count how many check-ins there were for each, independent hour, for each independent weekday. And then, or for the day string, this is just counting how many there are for each unique string here for this year, month, day in a string format instead of a date format. And then the output for this check-in aggregation should be, that we see our total check-ins, and then we have check-ins by day, and we have our check-ins by hour, check-ins by weekday. So this here is for weekday, like this is weekday number 1, we had 2, we had weekday number 5, 1, things like that. And so then this is by, since we did this for each business ID, it divides it up by business ID. So yeah, so we added it for each independent business ID by defining up here what our dictionary was and how we could get this for each business ID divided up. So that's kind of, that was a very complicated exercise that we kind of saved until the end. But that wraps up our case for today for some different ways that you can actually clean your data. So we went through a couple of different methods where we could, just replace our missing data with a NaN instead, that we could replace missing data for dates with incremental segments. We went through different ways that we could actually fill in data based off of other columns. And then, here we did a little bit of analysis at the end. And so, I think all of these, like I said, these were kind of complicated ways to do this code, but I like to think of them as like a model or an outline or kind of a structure for how you can use these things in the future. If you ever needed to know what code should I use because I want to, fill in my date values incrementally, or I wanted to fill in something based off of other columns. So yeah, I would say spend some time. I think the code will be posted in polls and answers for number 9 here. But otherwise, I will go ahead and stop here so that you can have your break before your next lecture. And yeah. I think that's it. So thank you all very much for your attention. And yeah, that's it for me.
Thank you so much, Sarah. Was awesome lecture. So guys, we hope you have liked it, and we are going to have like a little break and be back around like 10:15 to another amazing lecture. Okay. See you soon, guys. Thank you, Sarah, again.